Hello, my name is Dr. Dennis Spence. I'm one of the faculty in the Texas Wesleyan University um, DNAP program. This week, I'm going to be talking about giving you an introduction to biostatistics. So here's our learning objectives. You can read over them, but in summary, what we're going to do is I'm going to first talk about the scientific research process. We'll go through that throughout the lecture. We're going to talk about the difference between a purpose statement, or research question, and a hypothesis. My hope is that you'll be able to understand the different ways we collect data for a research study. We'll talk about differences between a statistical sample and a population. We'll review the different classifications of variables, as well as looking at definitions of an independent and dependent variable. And throughout, I'm going to provide you with some examples on these. And like I said, this is just a primer for what's to come in the remaining weeks of this course. And then at the end, we're going to conclude with some discussion of how statistics may be misused, or people may use misleading statistics. After you complete this series of video clips, and what I've done is I've tried to keep them in short clips for this whole lecture, so you may have to watch multiple videos and they just follow in sequence. And then after you're done going through this lecture, you also have a copy of the slide deck in a PDF format. But we also would like you to go through and watch these video clips on YouTube. The first one is a nice quick overview of the scientific method. The next one, the role of biostatistics in research, is by a friend and mentor of mine, Dr. Riffenberg. It's just under 50 minutes. It's a really good review of biostatistics. I think it'll help reinforce some of the concepts we talk about here. And Dr. Riffenberg is a statistician who's written tests. Who's at the Naval Medical Center in San Diego, and he's authored a biostatistics and medical research book. And then I want you to look over the next video on probability and statistics. Several of them are actually from Khan Academy, which I found to be very informative, concise, and to the point. And in the end, I'd like you to watch the video by Sana Blau from a TED Talk, and she talks about how to defend yourself against misleading statistics in the news. It is important that you watch these videos because you may or may not see questions in the quiz this week related to them. So why do you need to learn about biostatistics? Well, it's going to help you to really evaluate, interpret current research data. It's going to help you in your program. And really what your whole goal in this DNAP program is, we want you to be able to translate research evidence into practice, to be able to evaluate how our practices are doing, and how you can use evidence to guide or improve processes or projects. Maybe a QI, PI, or an EBP project at your institution, and allows you to maybe also be part of a team that's conducting one of those projects. Now, I know many of you are probably thinking, gosh, I had statistics years ago. Maybe I had it in my undergrad program or in my master's nursing anesthesia program, and it scared me to death. I hated it. I had to learn all these calculations and formulas. Well, this class is really not about that. It's really it's called Applied Introduction to Applied Biostatistics. So we want you to really focus in on understanding the concepts, and very little of it is going to be related to any sort of understanding of actually how to calculate things. We may touch on some of that. We may have you do some use some online statistical tools to help you calculate, or just help to reinforce the concepts we talk about. But really, the majority of the content focuses on statistical theory and terminology. And you really need to know this information, as it helps set you up for success in your later courses. So our agenda, we're going to talk initially about, we'll go over what is statistics, what is a statistical study, what are some examples of misleading statistics, and then we'll touch on some software that you may or may not be familiar with that you may see researchers and statisticians using, or you may in fact have some experience with. So statistics are facts that help describe or summarize data. It's also considered the science of data analysis, which can include how you collect, organize, or analyze and interpret the data that you collect in a research study. So really the simple steps, if I'm going to break it down for you, is initially you're going to develop this research question, you're going to formulate maybe a hypothesis, maybe a prediction about something that you're interested in. Maybe there's a clinical problem. You're going to design a study around that hypothesis. You're going to gather some data. You're going to summarize that data, and then you're going to draw inferences or conclusions from that data. And that's an example of how we might test a hypothesis. What is biostatistics? Well, biostatistics is the processes and methods that we apply when we're collecting data, biological data. And this is really in relation to what we do every day in anesthesia practice, but also in human biology, health, and in medicine. Here's some examples of things that you're exposed to every day where statistics are used. For example, you may see this statement in an ANA publication that the median annual CRNA salary is about $175K in 2018, with a range of $161,000 to $191,000. So that's from the lowest to the highest value. Also, it's not uncommon that we see incidences of adverse events in anesthesia, the most common being post-op nausea and vomiting. You know, in some patients, the general incidence may be as high as 50%. Or you may see the last statement where you're reading nothing related to medicine, but it shows you how square footage of homes have changed over the last 40 years. And throughout this course, you guys are going to learn how you can make those statements from data that you may collect or you may read about, or it's going to help you understand the meaning behind statistical statements. Or when you go through and you read a published article, you'll be able to really understand that statistical methodology section and and really understand the results section, as opposed to like what most people do is they just read the beginning and the end and look at the conclusion and just assume that everything else is okay, which in fact most of the time it is, but sometimes even through the peer review process, sometimes correct statistical tests are not exactly used. So you need to understand these so that it helps you appraise the literature. So what can statistics do for you? It can provide a summary of numeric information in a concise manner. It can help you understand and test hypotheses. For example, a hypothesis would be maybe patients who receive multimodal analgesia will have significantly less postoperative pain when compared to those who do not. It may help you in comparing information from different groups. For example, how does the outcome of patients receiving treatment X compare to those receiving treatment Y? And it can help you make predictions. This is commonly when we're doing regression analysis, which we'll talk about in later lectures. But this might be help you answer a question: when will I need to redose my epidural or redose my muscle relaxant? This is a quote actually from Dr. Biddle's book, and he's helping to provide this example to illustrate how statistics can help guide our practice. So here's an example. Statistics can help you make a decision. We were just talking about PONV risk factors, and here's the PONV consensus guidelines from the Anesthesia Analgesia article in 2014. So, for example, you have a patient who's undergoing getting scheduled for a lap chole. She's 40 years old, and she's got 3 risk factors for PONV. So what you could do, if you really do understanding and how to apply statistics, you can go to this article and you'll be able to understand how they came up about with those results, and you can take that to apply it to practice. And in fact, based on this and your understanding of the literature, you decide to administer prophylactic emetics and Ativa to this patient to reduce her risk of PONV. It's also about, it helps us make decisions. Here's another example where we take the data, we calculate some statistics, and it informs our decisions. I made up some example MBCRNA C exam scores. This is the exam that our students take when they're in their training, and it helps us kind of focus their learning and see where they're weak. It also helps with program evaluation for us. But you can see, for example, I've got 5 different student data results here where I've made up some different scores for their C exam. And then in the statistics column, you can see that I have some example statistics that you may calculate from that data set. And then you can make an informed decision is that maybe when you look at this data, overall my sRNAs do pretty well. And these results might help you identify weaknesses in your program and where you need to buff up your curriculum. It also might help you identify which students need remediation. So that's one of the reasons why statistics is important to us. So now I'm going to pause the video clip and go ahead and when you're ready, start the next clip and we'll continue the lecture.